Hey everyone, a very warm welcome back to the channel. Today we have a question number 6 from the chapter of monotonicity and maxima minima. The question is asking us to find the number of roots of the given equations. First part is cos of ln x is equal to ln of cos x belonging to e power minus pi by 2 to pi by 2. Second part is sine of tan x is equal to x, where mod x is less than or equal to pi by 4. Third part is sine square theta is equal to theta into sine of sine theta, where theta is from minus pi by 2 to pi by 2. Maximum time allotted for this question would be 12 minutes, and ideally you should try to do it within 7 minutes. So you can pause the video, give the question a try, and then return back to have a look at the solution. So I hope you all have tried it out. Now let's see how many you have got correct. So the answer would be uh, 0, 1, and 1 for first, second, and third part. Now, let's see how to solve it actually. So concepts and formulas used are very simple. Derivative greater than 0 means increasing function. Derivative less than 0 means it is a decreasing function. And derivative sign change from negative to positive means it is a point of minima. And that's pretty much it. So let's now see how to solve the first question. So the very first part is probably the most difficult part probably to think about is this function. We have to consider the function x minus ln x, and this is quite counterintuitive. It really takes a long time for anyone to think, and for x greater than 0. But once you have thought of this, the reason I thought of it was because cos ln x is FOG, and ln cos x is GOF. So even though they are not inverse functions, but just it crossed my mind, why not let us consider the line y equal to x, and that's how I was able to think of this function. And I mean, yeah, certainly it is very difficult. So even if you have not been able to think, then no problem. From the question now you'll be able to learn this technique. So the derivative f prime x would come out to be this quantity, which can be written like this. Sign scheme we have made here. Clearly, x equal to 1 is a point of local as well as global minima. The reason is sign is changing from negative to positive. So at 1, it will have a minima, right? But then it continuously increases, and before that it was continuously decreasing. So clearly, this is the minimum value, global minimum also. No value can be lesser than this, right? Since it is increasing after this, earlier it was decreasing. So that's why f of 1 comes out to be 1, which is greater than 0. So since the minimum value itself is greater than 0, so f of x will also be greater than 0 for all x, for all positive x, right? So x greater than ln x, because f of x was x minus ln x, it is positive, so x must be greater than ln x. But it is given to us that x lies in this interval, so x would be greater than 0, of course, because this thing is obviously greater than 0. So we can say on taking logarithm all the sides, we can say minus pi by 2 is less than ln x is less than ln pi by 2. But if I use 1, I can also say ln pi by 2 is less than pi by 2. The reason is that we have already proven ln x would be less than x, so ln pi by 2 would be less than pi by 2. So obviously ln x, since it lies between minus pi by 2 and pi by 2, it means it is an angle between in the fourth or the first quadrant. So cosine of it, when we take, it would be greater than 0, because cosine is positive in the fourth or first quadrant, both the quadrants. So but the thing is that in the given interval, since we have seen that x lies from 0 to pi by 2, cosine would obviously be positive and less than 1. So the logarithm of it, if I take ln both sides, so it would be less than less than ln of 1, which is 0. So cosine ln x, we have shown that it is greater than 0, but 0 is greater than ln cos x. So clearly this thing is greater than this, so they can never be equal in the given interval. So no solution, no root, no real root. Second question now, second part if we take a look at, then f of x would be sine of tan x minus x. This we can consider derivative we find, this it comes out. Secant is square x, then we can write it as 1 plus tan square x, and then we can open up the brackets. So cos tan x into 1 is cos tan x, then minus 1 is here, then tan square x into cos of tan x is here. So obviously, since everywhere we are able to observe that we are only having tan x, so we can say that t is equal to, let's put t equal to tan x, so that t will range from minus 1 to 1, because x lies from minus pi by 4 to pi by 4. So if we take, since tan is an increasing function from minus pi by 4 to pi by 4, so its range would be tan of minus pi by 4 to tan of pi by 4. But Those values are -1 and 1. So that's why T range we have been able to find. So f prime x can then be written as this thing. I've simply put tan x equal to T. So now what we are doing is cos T minus 1 I am writing as -2 sine square T by 2, right? Using some multiple angle formulas. And then what I'm using is that sine square theta is always less than or equal to theta square. This is very obvious because for positive theta, we know that sine theta is less than theta for positive, and even less than equal to, we can write it theta equal to 0, 0 is included, right? So actually we can say that this is always true for real theta. So squaring, we get sine square theta is always less than or equal to, theta square. So that is exactly what I've used here. But since there is a negative sign, the inequality sign has reversed from less than equal to greater than equal to, and then t square cos t square cos t is both the sides. So it doesn't even matter. So this basically becomes f prime x is greater than equal to, if we take t square common out common, then we have cos t minus half. But we have already observed that mod t would range from 0 to 1 because t lies in -1 to 1, but 1 is clearly less than pi by 3 because pi is 3.141 something. So if I, and obviously this is less than pi by 2, right? So from 0 to pi by 2, cosine is a decreasing function. So if I take cosine both sides, so cos of mod t, the inequality sign reverses, and cos of would be greater than cos pi by 3. So cos pi by 3 is nothing but but half. So transposing it to the other side gives us cos t minus half greater than 0. And obviously, since this is greater than 0, this is anyway greater than 0. So f prime x would be greater than or equal to 0. So f of x increases in this interval, but f of 0 equal to 0 very easily we can observe. So this will be the only root. It's very obvious because at 0, it has got some value 0 only. And then since it is increasing, so it has to go like this. Moreover, it is an increasing function. So it is also a 1, 1 function. And since it is a 1, 1 function, what can we say? We can say that every value it can only attain once. So if at 0 it attains 0, there will be no other value at which it attains the same value. And the only reason why we are saying that f prime greater than or equal to 0 is that we can say that f prime 0, actually f prime 0 will come out to be 0. But the problem is that even if this kind of a function we are having, its f prime x is also greater than equal to 0. So one value it can attain many times. So how can we be sure that at 0 it is only attaining it once, right? So let me explain. What we can observe is that if you put it equal to 0, that is only happening at a single point, at a discrete point. Okay, discrete means it is not forming an interval. And what is that point? When t is equal to 0 or x is equal to 0. So basically the point here is that in the given interval, it only becomes equal to 0 for a brief time. That's something that we need to understand. For a brief means at a discrete point. So at a discrete point being 0 means at that point it becomes 0, but then it starts increasing, and earlier also it was increasing, just like x cube. X cube also derivative becomes equal to 0 at x equal to 0, but it is still a 1, 1 function, a strictly increasing function. In fact, it is. So it only attains 0 once. Okay, so that's something that we really need to understand, that derivative only becomes 0 at a discrete single point. So it is a strictly increasing function, and that's why any value it will only attain once in the given interval. Third part, now let's talk about clearly theta is equal to 0 satisfies the equation, right? So if theta not equal to 0, then sine theta not equal to 0. So on division, we can write this, correct? So that's pretty much it. And once you have written the equation in this form, the question is very straightforward. F of x equal to sine x by x we can consider, where x is from 0 to pi by 2, even though we were given minus pi by 2 to pi by 2. Right now we are just assuming it to be positive and acute angle. So f prime x, if we find, it comes out to be this, and on simplifying it becomes, or manipulating, it becomes this. But this is all positive, right? And x, as we know, is always less than tan x in acute, whenever it is an acute angle. So this entire thing is less than 0. So f of x is a decreasing function, and thus a 1, 1 function in 0 to pi by 2, right? So f of theta equal to f sine theta. Look, this is f of theta and this is f of sine theta. So when we are saying that f of theta equal to f sine theta, it would imply that theta is equal to sine theta. But this is not possible because for all acute and even a positive theta, we know that theta is always greater than sine theta. So they cannot be equal. So there will be no root in this interval. But we observe that this and this are both even functions. So if they don't have any solution in 0 to pi by 2, they won't have any solution in minus pi by 2 to 0 also, right? So the only solution is theta is equal to 0 in this particular interval. So I really hope these questions you were able to understand and have a greater understanding of AOD monotonicity and helped you in your preparation. Make sure you like the video, comment down below what you would like the most and what more you would like to see on this channel, and share it with your friends. Subscribe to the channel, hit the bell icon to never miss an update, and I'll see you all in the next one.